Okay, so now that we know how to simplify rational functions, we're going to talk about how to multiply and divide them. And so I want to make an analogy to multiplying and dividing fractions because the same process applies. And so if we wanted to multiply this 15/8 times 2 over 35, we could multiply the 15 times the 2 and get 30, and then multiply 8 times 35 and get a big number. Or what you can do is you can simplify first. And so if you want to simplify first, you have to factor each of the numbers. And so for numbers, it's the prime factorization. And so I can factor 15 into 3 times 5. I can factor 8 into 2 times 2 times 2. And then 2 is already prime. And then 35 is the same as 5 times 7. Okay, and so with this, when you are multiplying fractions, you multiply the numerators and multiply the denominators. And so I can write this as one big fraction. The numerators would be 3 times 5 times 2. And then the denominator would be 2 times 2 times 2 times 5 times 7. Okay, and so remember, division, which is this fraction bar, cancels with these multiplications. And so any factor that you have written on top and bottom cancels out. And so I have a 2 on top and a 2 on bottom. I have a 5 on top and a 5 on bottom. And so when I simplify this, the only thing left on top is a 3. And then the only thing left on bottom is 2 times 2 times 7, which is 28. Okay, and so if you were to multiply 15 times 2 and get 30, 8 times 35 would give you, I don't know, 240 plus 4, 280. And so you would multiply that right off the bat and get 30 over 280. But then you would want to simplify that by dividing the top and bottom by 10 to get the simplest answer. Okay, and so both methods work for multiplying numbers, but when you get to these functions, you are definitely not going to want to do that. You're going to be multiplying a quadratic times a quadratic. And then if you don't simplify first, you're going to end up with degree 4 polynomials, degree 5 polynomials, and you don't want to do that. And so you're always going to want to do the simplifying and crossing things off like I did here. Okay, and so 1 said rewrite problem with numbers factored. That's what I did in this second step here. And then 2 says how do you multiply fractions? I just mentioned that you multiply numerators, multiply denominators. Okay, and then after you do that, simplify. Always, always simplify if you can. Answers not in their simplest forms will be wrong. Okay, and so this same process is going to apply when we're multiplying rational functions. Our first step is going to be factoring everything in sight. And so we are going to try to multiply f of x times g of x. That's what this dark circle means. Multiply these two functions together. Okay, and so f of x is a quadratic over a quadratic. And so first we want to factor the numerator and denominator. Okay, and so for the numerator, we're trying to find two numbers that multiply to -2 but add to -1. We would need the 2 to be negative, and so that factors to x minus 2, x plus 1. For the denominator, we can't use the shortcut, so we're going to have to split the middle and factor by grouping because of this leading coefficient. And so we need two numbers that multiply to -4 but add to -3. And so that would be 1 and -4. And so we're going to use that to split the middle. And so we're going to do 2x squared plus 1x minus 4x minus 2, factor by grouping, leaves us factor to negative 2. And x minus 2. Okay, so that factors to 2x plus 1 and x minus 2. You want to be very careful when you're factoring. If you factor wrong, your whole answer is going to be wrong. Okay, we also have to split the middle and factor by grouping for this one. So we need two numbers that multiply to negative 6 and add to negative 5. Okay, so to get a negative, we would need the 1 and negative 6. If you chose 2 and 3, both of those would have to be negative, but then they wouldn't multiply to negative 6 anymore. And so these are our numbers. So 2x squared plus 1x minus 6x minus 3. So this factors to 2x plus 1 and x minus 3. And again, just like we talked about last semester, it doesn't matter which order you write these in. It's all getting multiplied anyway. Okay, and then for the bottom, this x squared plus x, there's a GCF of x involved. And once you factor that out, you're done. So x times x plus 1. That was just a GCF type. Okay, and so now if we rewrite this as a product, we would have x minus 2, x plus 1, 2x plus 1, x minus 2, x plus 1, and okay, and just like we talked about up here, you can write this as one big fraction. And so really, we don't need this dot here. We can write this all as one big fraction. Okay, and so any factor on top, any of these 4 factors on top, if there's another of that factor on bottom, you can cross it off. Okay, and so I'm going to switch to black and we're going to cross things off. So I have a 2x plus 1 on bottom and a 2x plus 1 on top. I have an x minus 2, x minus 2, an x plus 1, and an x plus 1. Okay, and so what is left on top? All we have is x minus 3. On bottom, all we have is this x. Okay, expressions remaining in the numerator is x minus 3. Expression remaining in the denominator is just x. And so our final answer is x minus 3 all over x. Okay, be very, very careful. Do not cross off these x's, just like we talked about in the intro. This is subtraction. Division cannot cancel with subtraction. And so this is our final answer, and it can't be simplified any more than that. Okay, so that's multiplication. All you do is factor everything in sight, write it as one big fraction, and then cancel any factors that appear on top and bottom. I call multiplication the cancellation game, because literally you're just factoring and canceling things. Okay, and so for division, it's a very, very similar process, only you have to remember how to divide fractions. And some of you learned flip it and multiply. Some of y'all learned keep, change, flip. I saw that on the fractions review. And so you keep the first fraction, and then you flip the second fraction. Okay, so keep the first and flip the second. So now it's 25 over 6, and you change it to multiplication. Keep, change, flip. Okay, and so I'm going to go ahead and fill that in. Keep, change, flip. So that means keep first fraction, change to multiplication, and then flip second fraction. Okay, so if you know how to multiply rational numbers and rational functions, you can divide, because all you have to do is flip the second and multiply. Okay, and so we're going to do the same process we did before. We're going to factor everything in sight. 3 is already prime, 5 is already prime, 25 is 5 times 5, 6 is the same as 2 times 3. And so we multiply fractions by just writing it as one big fraction. And then we cancel anything that shows up on top and bottom. So there's a 3, there's a 5, and so we're left with a 5, and we're left with a 2. And so 3/5 divided by 6/25 equals 5/2 in its simplified form. Okay, and so now we're going to do that with rational functions. And so it says, try to find f of x divided by g of x. That's what this means. Okay, so if f of x is this rational function and g of x is this rational function, they may write this as f of x, and you're going to see this on a test and a practice worksheet maybe. F of x divided by g of x. A giant fraction. Okay, so if you see that, don't let that scare you. Just put parentheses around f of x and then parentheses around g of x to kind of help you group it together. Okay, and so step 1 is write the problem as an equivalent multiplication problem. So instead of writing it as this huge division problem, we're going to keep the first. Don't change anything about f of x. Change to multiplication, which they've already done for us, and then flip the second. Do that first so you don't forget to flip. Okay, now we're right back to what we did on page 1. We're back to multiplication. And so now we just need to factor everything. Okay, and so if we're factoring f of x, let's start with the top. We need two numbers that multiply to -6. Add to -1. It's going to be -3 and +2. Again, take your time with these, because if you mess up your factors, nothing's going to cancel, or things are going to cancel that shouldn't cancel. We need two numbers that multiply -4 to add to 3. This time the 4 is positive, 1 is negative. Two numbers that multiply to -8. We can use the shortcut on all of these. So that would be 4 and 2, and 2 would have to be negative. And then for the bottom, need two numbers that multiply to 6 but add to -5. So this time we would want the 2 and the 3. Make them both negative, then they still multiply to +6. Okay, so now we can write this whole thing as a product. F of x times, I'm not going to call it g of x because we flipped it. And then remember, anything with multiplication, one big fraction, anything on top can cancel with anything on bottom. Okay, so x minus 3, we can cancel these x minus 2s, we can cancel these x plus 4s, and so all we are left with is x plus 2 over x minus 1. And so our final answer is x plus 2 over x minus 1. Okay, so factor everything in sight, write it as one big fraction, and then cancel anything you can.